sliding filament model describes the process used by muscles to contract. At a very basic level, each muscle fiber is made of small fibers called myofibrils. These contain even smaller structures called actin and myosin filaments. These filaments slide in and out between each other to form a muscle contraction. The sliding filament model describes movement as a cycle of repetitive events that causes actin and myosin myofilaments to slide over each other, contracting the sarcomere and generating tension in the muscle. The amount of force and movement generated by an individual sarcomere is small. However, when multiplied by the number of sarcomeres in a myofibril, the amount of force and movement generated is significant.
A neuron will pop, releasing the neurotransmitter acetylcholine. These neurotransmitters bind to the sarcolemma, and this goes into the T-tubules. The T-tubules triggers the release of calcium ions by the sarcoplasmic reticulum. This will initiate the contraction of the muscle. After the calcium is released, it will bind to the troponin, changing the tropomyosin complex. This change exposes a thin filament, actin. Myosin cross-bridges form when the myosin heads bind to the active sites. This causes a patterned process of cross-bridge binding, pivoting, and then detachment. This is all powered by ATP. This pattern will continue until one of two things happens. ATP runs out, which means death, or calcium is reabsorbed by the sarcoplasmic reticulum. This is when the signal runs out and you tell your muscles to stop contracting. This will cover the active sites again, and all components will return to the resting state.